Hello everyone, my name is Saad Oda. I am a TA for Fluid Measurement, Lab 4 for EMCH 361. The main objective in conducting experiment on a fluid measurement in a pump and piping system are to learn pressure measurement in a fluid system using differential pressure sensor, learn flow rate measurement in a fluid system using Venturi flow meter and paddle wheel flow meter. Finally, observe the relationship between flow rate and pressure drop of a fluid system and how they are affected by the input power. To find the relationship between actual flow rate and the pressure drop, you need to use the continuous equation. From the continuous equation, we can see the Venturi this is A1, V1, A2, V2. So A1, V1 equal A2, V2. Since A1 more than A2, then V2 more than V1. And with a Bernoulli equation, you can find P1 over gamma plus V2 over V1 square over 2G. Z1 equal P2 over gamma plus V2 2G plus Z2. From this relationship, you can find this equation. So where Q actual volumetric flow rate, make sure to use the right unit, meter cubic per second. C is the discharge coefficient and velocity of approach vector. Rho fluid density. So in this lab we are going to use the fluid water, use the water density of the water at temperature 20 cent. And then you can find from the table, from the Google you find a density, make sure to use the kilogram per meter cubic. Finally, GC is a constant, and this is the unit number 1. Figure 1 shows the schematic of the experiment facility. So the water flow loop is designed to supply a constant flow rate of water to the test section, which is Venturi tube at desired temperature and pressure. This open system is called open system. Centrifugal pump is used. This is the centrifugal pump is used to pump water from the reservoir tank to the test section, which is Venturi tube. Goes through paddle wheel flow meter, control valve, Venturi tube, and then to the out, which is the reservoir tank. Flow meter, paddle wheel, this is the paddle wheel flow meter, and Venturi meter is used to measure the flow rate, and actual flow rate is used to measure the flow rate, which is calibrated by using it's called bucket and stopwatch to find the actual for it. We will measure it at lab. I will show you. From this figure, the three three sensor. Let me use a different color. Oops, three sensor. Is used to measure dB. This is the sensor 1 here. This is sensor 1. Here the sensor 2, B2. Here the sensor B3. You can see this is B1, B2, B3. Or we can say call the B1, B2, and B3. These three sensors are used to measure the differential pressure between in, out, between in and out. This one, in and out. Sorry. In and out, between in and out. And two sensors. Two are used to measure flow rate, Q, flow rate, meter cubic per second, from the paddle wheel. This is flow rate 1, Q1, here measured by flow rate, this paddle 1, and second one, Q2, from the Venturi meter. We will get it from the LabVIEW program. I will show you. And the third one, flow rate, which is called actual flow rate. We will calculate the flow rate. This is the actual pictures for the experimental setup. You can see this is the reservoir tank, centrifugal pump, the power meter. This is the power meter. It's called power supply, used to run the centrifugal pump. Is we can get the power, which is watt, from this directly get it. The centrifugal, as we said in previous, to pump water through the paddle wheel, mechanical valve or control valve, and Venturi tube. And here these sensor, as we say, this sensor connected sends a signal to the DAC. Here this is the DAC, and then from the DAC there's the UPS connecting to the computer. There is a LabVIEW. From the LabVIEW we get all the value that we need to calculate or to find the relationship between flow rate with differential pressure, and then how they are affected the power with the power, which is what. So the question 1, what are the instruments that will be used in your fluid lab? So the instrument that will be used in your fluid lab, centrifugal pump, which is this one, mechanical valve, this one, this two, or keep it this A, this B, this A, this B, Venturi tube, C, paddle wheel, flow rate, D, pressure sensor, which I already explained in the previous, I think, slide. So there is a 3 sensors for a pressure drop. So question number 2, what are the quantities that need to be measured? What's the quantity that we measure in this lab? Measurement of differential pressure and flow rate. Differential pressure and flow rate. Yeah, make sure these very important question, 2 questions. This is sample data. So you can see here the trial 1. This is a process. The process is repeated for at least 5 times to analyze the changing independent variable. So the actual flow rate, this is the actual flow rate. Actual flow rate will measure to compare the performance of the flow meter, which is calibrated by bucket and stopwatch method. So this is the actual valve. So to get a different condition, we need to change the valve. Differential pressure, venturi, this one. So which is a mechanical valve. Here you can see this is the we can see this is B in and this is B out. So when we change the position of this valve, when we make this area reduce the diameter, it means increase the B in. So always B in more than B out. It means dB equal B in minus B out. So when we increase the cross-sectional area here, so first make it fully open, 0.2, and then after that we decrease the cross-sectional area. So BI will be increased. This one will increase. Once we make this area small, BI increase. We get 0.76. And then we increase the area also, make it 1.12, the fourth one, 1.56, the final one, 2.17. So by changing the control, the mechanical valve or control valve, we get a different condition. When we change this value, we will get a different value of power. By changing this area, the power we will get the less power, and obviously we'll get less actual flow rate. So, and then just I want to mention about to convert the venturi delta P. Make sure convert inch of water to the PSI. So this value 18.26 times 0.036092 to get a PSI. And if you need to make it a PSI, you'd unit or make it a Newton per meter square, whatever you like. Okay, I will send you an Excel file. So this data just showing how to do the calculation. Okay, thank you. Question: what are the independent and dependent variables for the fluid lab? So the independent, flow rate, dependent, pressure drop, differential. Okay, so in your report you need to make a table like this, but a different value, the value that I will send it to you when we get it from the lab, when we record the video. This is trial 1, 2, 3, 4, 5. This is the actual flow rate. Actual flow rate, gram per minute, 5 value, and pump dB for centrifugal pump, BSI. Make sure to use the right when you draw or when you calculate the error or calculate the efficiency. Make sure use the right unit. So you need to draw a figure which is differential pressure for centrifugal pump. Centrifugal pump, right? This is the centrifugal pump. With the actual flow rate, it is observed that the differential pressure, you see, observe the differential pressure decreases with the decrease with the increase flow rate for actual flow rate. Okay, yeah, this is the figure 1, and then I will show you how from the second slide. So you need to draw two figure, the relationship. So draw the relationship between control valve and actual flow rate. The second one. The third one, find the between Venturi and actual flow rate. Venturi delta B. Venturi delta B. So here you can see the delta B for control valve. You can see you need to put a unit. If you use PSI, put the PSI. If you use Newton per meter square, you need to put meter per Newton per meter square. And with actual flow rate, and also if you need to put the gram per minute, or if you say no, I want to use meter cubic per second, whatever you like. But make sure if you use the gram per minute, use with the PSI. If you use meter cubic per second, you need to use Newton per meter square. Okay, so you should get for the valve, you should get like this, and then you need to explain why you get this relationship. Decrease the flow rate with decrease in the pressure drop or whatever. The third one, this one, the third one, delta B, for what? For Venturi. Delta B with actual flow rate. You should get figure like this, and then you give the reason why you get this figure. What is the relationship between delta B for Venturi and with the actual flow rate? Why you get this? Okay, I give explain and then discuss in your report result and discussion and give details why you get this. Okay, thank you. So you need to calculate from the data analysis. First, we can calculate the error of the flow rate. How to calculate the error of flow rate? You need to make a table like this table for the 5 trial. The actual flow rate, this is the absolute value. Make sure to add the absolute value. Measurement, the measurement that you get, the measurement for, let's say, for example, for bottle wheel, 2.93 minus actual flow rate, 2.1 divided by actual flow rate, which is 2.91, and then you give me the percentage for the actual flow rate for the bottle wheel and for Venturi meter, and then you need to draw or make a table to give me the Venturi error and bottle wheel error. Okay, let's move to the third table, pump efficiency. Calculating the pump efficiency, the trial 1, 2, 3, 4, 5. Delta B for centrifugal pump with the actual flow rate, and then with the power, calculating the pump efficiency. And delta B, you need to use the right unit. If you use a British unit, flow rate PSI, so flow rate per minute, and delta B use the PSI. Or if you use SI unit, you need to make sure that delta B, here you can see the efficiency delta B in Newton per meter square times meter cubic per second over Newton times meter per second. And this is dimensionless. Multiply 100, and then you get the efficiency. This is just example. This is the sample, and then you need to explain the relationship for the pump also. And finally, discharge coefficient. How calculate the discharge coefficient? You find the Venturi. This is the Venturi dB. As I told you, need to make sure to change the unit. Make it unit. This make it EINWC to PSI. Make sure to convert to the PSI. Or you can see Newton per meter square. You can figure out. So A1, this is the A1, this is the A2. How to find the A1? You find the A1 equal pi over 4 d square. D is 17.2.6 millimeter. A2, which is equal pi over 4, 8.8 this millimeter square. Make sure unit is correct. Use it. Convert millimeter square to meter square. It's very important. And then how to find the discharge? Q actual equals C Q ideal. You need to find the Q ideal. B1 minus B2 is the Venturi. Make sure to use the P1 minus B2 for Venturi. Venturi dB, Newton per meter square. Some student, a mistake, they use the dB for the pump, which is wrong. Okay, or use delta B for valve. That's wrong. Use delta B for Venturi. This is the purpose we using the Venturi meter. To use the Venturi a tube is to change the cross-sectional area. When we have a small area here, the small area, the pressure drop B. If we have B1 here and this is B2, so B1 always more than B2. Okay, a high velocity with the pressure drop here, the pressure drop less. Okay, and GC 32.17. Make sure the unit use it, and the area use it meter square. Once you find the A1, A2, and then you apply in this equation, you will find the C. Give me different value of C, right? Because the different delta B, it will give you a different C. So this is your calculation. Finally, thank you so much. I really appreciate that you took the time to listen to my presentation. Please feel free to contact me by either telephone, call me, or email me. I am willing to help you. Thanks.